Can you people hear me clearly?
Yeah.
Okay. So myself is Naresh Kabati, working as a senior Oracle database administrator for the top IT firm, more than 5 years. So, so this is about my experience, and shall we have about your introduction? Pradeep, can you
Yeah.
introduce yourself shortly?
Yeah. 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 My name is Pradeep. I'm looking for a Oracle DBA administrator job. So I have gap between 3 years.
Uh, okay. What is the qualification?
Yeah. BTech from JNTU
Okay.
in 2012.
Okay. Fine. And John?
Hello, my name is John.
Yeah.
I'm from New Jersey, and I'm a fresh graduate, and I'm looking for an Oracle training, and that's why I'm here.
Okay. Good. Next, Suchitra. Suchitra, are you there?
Suchitra,
I
you
guess
are on
she's on
mute.
mute.
Can you please unmute and proceed? Hello, Suchitra, are you there? Okay, I think he's not in front of the desk.
Yeah.
Can call him.
And what is the name of K? We have another name called K.
Yeah, his name is okay, Kevibana. Hello, hello, yeah, Kevibana, are you there? Hello. Yeah, like okay, please unmute and speak, Kevibana. Okay, okay. Yeah, and Suchitra and like other guys, mic is not working properly, so that's the reason they are not
Yes,
able to
yes.
unmute.
They have pinged me. They
Yeah.
have pinged us. Okay.
Okay, fine. Yeah, you can proceed.
It's okay. Fine. Uh, okay, fine. So if you have any queries, just ping me if your microphone is not working. Okay. Let's start with our session. Uh, So yeah, so today we are going to discuss about the basic level of the Oracle database architecture. So before moving to entire concepts of the database, so first we need to be familiar ourselves for the database architecture, how the internal performance and internal mechanism is going to work when clients are working and end users, business people, and application users are contacting the database. So today we are going to learn what is the architecture and what are the components involved in the database. So we need to be more familiar with this, and what are the memory structures involved in this, and what are the background processor helping to run the database perfectly, and what are the components are involved in logical structure, and what are the components involved in physical structure, and we need to correlate among them. So these are the four main parts and points we are going to learn today. So uh, the next thing is how important the Oracle database is playing a major role in the industry. So we have in industry we have a couple of databases which are emerging in the market, and the most but most of the organizations are going for the Oracle database only. So it is a key, data is the key for the business. So every organization store the data in the raw format, right? So for that we need to have a database. So even though from small company to big MNC companies, every company needs to have stored the data and secure the data. So companies most widely use the Oracle itself for the database. And this Oracle database has various operating systems. This Oracle database supports various operating systems like Windows Server, Unix machines like Linux, Sun Solaris, AIX, HP Unix. So these type of OS platforms we can work for Oracle database. And I cannot say this point why, because it is what is the demand in the market for Oracle database. I guess you people know it very well. We have a very immense of demand in the market for this Oracle. Because every company choose for the Oracle database, why? Because the performance and the support which is providing by the Oracle is really much appreciated. And many projects across the industry use Oracle as backend for deploying its various applications. Like say, we have a coding parts like Java, .NET, and C++. Everything, whatever the coding parts and applications which are using by the industry, they take the Oracle database as a backend storage for the data. So this is the main thing in the industry of Oracle database. And coming to our architecture, so database architecture, it contains three major parts. One is database instance, one is file structure, and one is data structure. So what is database instance? If we see Oracle database, so it just consists of a software modules and database files. Database is nothing like we can say in one word, like it is a physical structure. Oracle database is a physical structure which contains all the physical files. And if we come to instance is a logical structure which doesn't exist. It will start when a user connected to the database. It will create the session for the user, that is called instance. When we start the database, one instance is created with all the memory structures. Okay, so if we see here, after the complete installation of the Oracle binaries, when you start the Oracle database, once the binaries and database is created, if you start the database, then it is referred to Oracle database 11g instance started with the operating system version. So it is the actual execution of DBMS software that manages data in the database table space. Okay. See, this is the clear architecture of the Oracle database. If you see the blue line, if you see this box, it is totally an instance. Instance is the command of the memory structures and background process, and this is called database. This is a physical structure. Okay, so instance is made up of SGA and background process. So what is just now I have said that instance is a logical structure, right? So the logical structure is a combination of SGA and background processes. So if you see this rectangular box inside it, it is having SGA, and SGA is once again SGA is having SGA is a combination of memory components. Okay, and this these circles, I mean except circles, are background processes: SMON, PMON, RECO, recovery process, and others, and DB writer, CKPT, log writer process. This is CKPT is called checkpoint process, and archiver. So these are the main process which starts when we start the database. If we have a log file, so if you monitor the log file in the database, you can see what are the processes are started when the database is started. And this box is called database, which is having physical files. Just now I have said database is a physical structure. So this database having physical files like database files, control files, online redo log files. If the database is in arclog mode, we have arclog files, and like password file, parameter files, network files. So these type of files will be existed in the database physically. So we have another memory called PGA, programmable global area, and SJ is called shared global area. Okay, and we have another process called user process and server process. So first of all, just see the architecture, what the database internally contains. So let's see the mechanism of this architecture in another slides. You people are clear about it, right? Can I have the confirmation?
Naresh, Jilani here. I think we are not able to see your screens. Yeah, till now we are on the only first screen.
Till now in the first screen itself.
Yeah, just now we got into the fifth screen directly. Okay, fine. You can proceed now.
Is it? Okay.
No, your screen sharing was stopped. Okay.
Yeah, I just stopped.
Okay, fine. Now we
Now
are
it's
able to
fine.
see. Yes, now we are able to see the fifth screen.
Now?
No.
Yeah.
Yes, now we are able to see. Thank you.
Okay. So shall I repeat it once again by seeing this slide?
John, Pradeep, Suchitra, are you guys clear or you want to repeat it? Please reply to instruct.
Or clear for you people?
Can you repeat it?
Yeah. Okay. So
Okay.
let's see. You concentrate on this architecture. This is the totally database architecture. How it have internal mechanism. See, the first rectangle box is an instance. So it is a logical structure. It will create when database is started. Okay. And if you see this down part, it is a database which is having physical files. It is a physical structure which contains data files, control files, and database files, archive retrieval of files. These are the main parts of the database. If we miss any of these files, the database gets crashed. So if we want to restore it, we need to have a valid backup. So this physical part is most important for the database. Okay, fine. So instance. So instance is a combination of SGA and background processes. If you see the rectangle box, SGA is a combination of components, memory components. Okay, SGA is nothing but shared global area. So in this shared global area, we have a combination of components like database buffer cache, read log buffer, and in shared pool, library cache and dictionary cache. These are the major components of the SGA. And we have a background processes like SMON, PMON, recovery process, DB writer, checkpoint process, log writer process, and archiver. So these are the main background process of the instance. If any of the background process had got killed or haven't started, the database will not be opened perfectly. So we need to check what is the problem, why the instance had not, why the background process had not started, and we need to troubleshoot it. Sorry. And we have another memory called PGA, which is outside of the instance, is called program global area, and we have server process and user process. So this is the entire architecture of the database. Fine?
Yes, it's good.
Yeah, it's clear.
Yes.
Yeah. So now let's see how the users connecting to the database. Okay. So connection is nothing but the communication between a user process and an instance. And a session. Session is specific connection for user to an instance through a user process. Okay. See, first the end user is trying to connect to the database. First, see, for example, we have accounts like Gmail account, or Facebook account, whatever it may be. If you enter your credentials, you can able to open your Gmail or whatever it may be. See, internally the mechanism is programmed like this is, if you entered your credentials, once the page is open for you and a session is created in database for yourself. So user session is created. Once you log out, the session will be closed and whatever the memory you utilize to open that session, it will be flushed out. Okay, so like that, in the same way, when an end user connects to database with his credentials, a session is created in the database. Like that, how many users are connected to the database, the separate sessions are created for them. So for example, user is connected to the database and a session is created. Okay, so he fires the select query. Let's say select star from EMP. Once the user fires that query, so the user process, whatever the user process is there, it takes the request from the user and it will connect to the server process which is at the instance level. Okay, so directly user process will not contact to the database. So user process gives the request to server process. Now the server process duty is to take forward the request to the database and get the output to the user. So this is how internally the mechanism works. Just brief mechanism. Users connect to the database, but once the connection is established, a session is created to this user. And when the user fires the query, the user process takes the request to the server process, and server contacts with the database and gets the output and gives the output to the user. This is how internally it works. Clear? I need confirmation from your people.
Yes, clear.
Yeah. Yeah. See how this is an interacting with Oracle database internally. We have just seen here briefly and internally how it works. See, once the user files SQL query, it are going to user process and the request going to server process, and as I told, instance and database, right? So for example, the user had fired select star from EMP or select star from table. So first it will not directly go to the database. First it serves in the SGA, which is called temporary memory area. Before giving output to the user, the database stores the information database buffer cache. It will store an image so that the same query if the user had fired in future, so it will not go to the database. It will get the information from database buffer cache and gives the output very soon. If the information is not available in the database buffer cache, it will go to the database and it will give the output to the user. Okay, so this is the internal storage structure. So memory structures of the instance, logical structure, and storage structure of the database, and these are the processes as I explained you earlier. See, let's see the mechanism of each of the memory component and background processor and physical file structures. So till now we have seen the architecture and how the users are going to connect to the database and how the internal mechanism is going to work. Now let's have a discussion about each of the memory component of the and background processes. So first start with database buffer cache. So database buffer cache, it is a part of the SGA. It is one of the component of the SGA, and it holds the copies of data blocks that are read from data files. Yeah, see, it holds the copies, means whenever the user files data, fires a new select statement, it gets the data from the database, and before giving output to the user, whatever the information captured in the database, it stores the data in the database buffer cache. It stores the image and throws the output to the user. So that is the point. Hold copies of data blocks that are read from the data files, and it's a shared by all concurrent user. Database buffer cache is a shared components. For example, if the another user had fired the same query, whatever it may be the user, so it will give the information from the database buffer cache itself. It is the functionality of the database buffer cache. And when it comes to redo log buffer, so redo log buffer is a circular buffer in the SGA. Okay, it holds information about changes made to the database. It contains redo entries that have the information to redo changes made by operations such as DML and DDL. Okay, so redo log buffer mechanism is it holds, it has the, I mean, whatever the changes are done in the database, so it holds the data. But for example, you are doing modifications in the particular table, like you are updating the table, you are inserting the data in the table, you are deleting the table, whatever the DDL and DML operations you are doing in the database end. So those modifications are started, those modifications will be stored in the redo log buffer. If you commit those transactions, whatever the DL and DML operations you do, if you commit it, the data is saved. If you are not commit, the data is not saved. So before committing, the data is stored in the redo log buffer. So this is the functionality of the redo log buffer. It will have the all DDL and DML operations, and it will have the information about the changes made in the database. When it comes to library cache, sorry, yeah, library cache and shade data dictionary cache, these two are another components of shade pool. So shade pool, it is a portion of, it is one of the components of SGA, and it contains library cache and data dictionary cache. See, in library cache we have a shared SQL area. Let me explain the functionalities of this. The data dictionary cache will have the all database related views, tables, packages, procedures, and everything. Data dictionary cache. And we have a control structures of this control structures of the database also. And library cache will have the shared SQL area. It is the main part on the SGA when library cache used for parsing the SQL. I guess you people know about the parsing. The parsing means, say the example, when user is firing select star from table name. So the first query goes into a library cache and it will do parsing. Like it will divide the whole statement into say different parts, like select and star from table name. It will parse and it will create the execution plan by the help of data dictionary cache. Okay, and then it will create a new execution plan for the query, and it will get the output from the database if the data is not existed in the buffer cache. So library cache is used for parsing the SQLs, and it will have the shared SQL area, and data dictionary cache will have the control structures and tables and views of the database. These are the main components of the shared pool in SGA. Now we have done with the SGA memory components. Now let's see how allocation and reuse of memory in the shared pool. The server process checks the shared pool to see if a shared SQL area already exists for an identical statement. Next, server process allocates a private SQL area on behalf of the session. I think now you guys are clear. So when server process will have the request from the user process, right? The server process will check first in the buffer cache if the data is existed. Otherwise, if the data is not exist, it will check whether the shared SQL area, I mean existing execution plan, is existed in the library cache or not. If the execution plan is existed, it will take the execution plan and fire the output. And it will also have the private SQL area on behalf of that session. It will create a private session for this user, so that he can have his own queries and fire in the database. So this is how allocation and memory is reused in the shared pool. Till now, is it clear, guys? Okay, fine. I guess it is clear for you people. Next goes to a large pool. Okay. Large pool. Large pool is also one of the component of the SGA, and it contains the session memory for the shared server and the Oracle XA interface. and it has the IO server process and Oracle database backup and restore operations. So large pool is mainly used for the backup and restoration. The main functionality of this large pool is, if for example if the database backup, if the database size is very huge, and to take the backup and to restore it, it will take much time, and we need sufficient memory. In that time we need to check the large pool whether the large pool is having sufficient memory or not. So if the large pool is not having sufficient memory, the backups or restorations will be hang. And as it shows, large pool is having IO buffer, free memory, and response queue and request queue. These are the four internal components of the large pool. What is the IO buffer? I mean, what is the IO size, and what the free memory is existed in this, and what is the response of the queue, and how much request we are getting from the queue. So this is the main parts of the large pool. And when this is about the large pool, and when it comes to Java pool and stream pool, yeah, Java pool is mainly used for when Java related codes and Java related functions are used in the database. In that time Java pool is used. Another in other parts of time the Java pool is not used much. So the main functionality of Java pool is used in server memory for all session specific Java code and data in the JVM. This is the main component specification of the Java pool. When it comes to stream pool is also mainly used when we are using Oracle streams. I mean, when we are using data replication. I guess you people know the difference between duplication and replication. So replication, we have the same data is transferred to other database. Whatever the data is there in our source database, the same data is transferred to target database using replication concepts. That is, in that time Oracle stream pool is used. So stream pool is used exclusively by Oracle streams to store buffered queue messages and provide memory for Oracle streams processes. This is the main specification of the stream pool. Okay. So in process architecture, let's say about the user process. As I explained you, user process is started when a database user or a batch process connects to the Oracle database. So it is created when a user is tried to connect to the database. And the database process, which is called server process, database process is combination of server process and background processes. Server process and background processes. Server process connects to the Oracle instance and is started when a user establishes a connection. User establishes session. And background process are started when an Oracle instance is started. As I explained you earlier, so background process started when a database is started, and server process starts after the user has created a session to the database. This is about the user process and database processes. And these are all the process structures. We have a multiple server process, like as I said, multiple users can have multiple sessions, and each user will have its own server process. Like if you see server, n number of server processes which are connected to instance, with instances combination and connected with the dependent background processes. These are the process structure. And let's see about the background for processes and how it supports the database to run. Let's say about the database writer process, DBWn. The N symbol states that we can have multiple database writer processes in the database. So it writes modified buffers in the database buffer cache to disk asynchronously while performing other processing. It periodically writes to advance the checkpoint and writes changed data from the database buffer cache to data files. Okay. So as I said, when the data is committed, so the committed data is written to database files using the database writer process. Okay. Whatever the uncommitted data is, it stores in the redo log buffer, and once the data is committed, so that it writes database data from the data files which is stored permanently. but with the help of database writer process. So the main functionality of this process is to write the modified data to database files from the database buffer cache. And when it comes to log writer, LGWR process, it's called log writer process. So log writer process writes the redo log buffer to redo log files on disk drive. When a user process commits a transaction, when the redo log buffer is 1/3 full, before a DBWn process writes modified buffers to disk. Yes. See, in the previous example I have showed you, redo log buffer. So redo log buffer contains the DDL and DML operations. So whatever the DDL and DML operations are there, it is stored in it. With the help of log writer process, DB log buffer writes the data into DB log file. It is a physical file. Yeah. It will resize the data from the DB log buffer to redo log files. The usage of log writer is writing the data from buffer to log files before writing the modified buffers to disk. So for example, if the database is not in arclog mode, so if the database is in arclog mode, the data is stored in permanently in the arclog files, and if database is crashed, we can have the backup and we can restore it. If the database is not in arclog mode, we cannot restore the database up to point of time. So redo log files have the uncommitted transactions. This is about our redo log buffer log writer. And when it comes to checkpoint process, so checkpoint process is we can say it is one of the important functionality in the database. So it records everything, like it records the control file sequence, and it records the data file header number, and it is responsible for signaling DB writer and log writer to write the contents of database buffer cache and redo log cache to the data files and redo log files respectively. Okay, so once checkpoint is occurred, whatever the data is written in the redo log file with the help of log writer, and at the same time whatever the data is written into the database files with the help of DB writer. So it will have, when the checkpoint occurs, those processes help the data to return into the physical files. It will have a checkpoint for that. So once the checkpoint reaches only, after that this process starts writing data from the respected files. This is the functionality of the checkpoint process. It will update the control. Once data is written into the database files, the checkpoint sequence is updated in the control file. The control file is updated in every second. It will update the sequence, and it will update the data file header, and is responsible for signaling DB writer and log to write the contents to database buffer cache, contents of database buffer cache and redo log cache to data files and redo log files. This is the functionality of the checkpoint process. And we have another process called SMON, which is called system monitor process. System monitor process performs recovery at instance startup and cleans up unused temporary segments. Performs recovery at instance startup means, for example, because of network issue and because of another issues, the instance had abnormally got shut down. In middle, when the transactions are going on, when the users are connected, and without any intimation, the database had shut down automatically. So we don't know what happened internally. So in that time, when we start the database once again, it will internally performs recovery to start the instance. When we start the instance once again, it will start without any issues. It will not show any errors like this is a problem, this is problem. So automatically internally it will recover it and it will start it. And another functionality is it will cleans up unused temporary segments. For example, as I said, when user is connected, a session is created to the user. A session is created means some memory is utilized by that session. So some memory is allocated to that session. So once the user is logged out, the session is closed. So whatever the memory allocated to the session, it is cleaned by the SMON. So this is the main two functionalities of the SMON. One is crash recovery and another one is cleaning the temporary segments. This is the functionality of the SMON. And when it comes to PMON, PMON is process monitor. It performs process recovery when a user process fails and cleans up the database buffer cache, frees resources that are used by user process, and it monitors sessions for idle session timeout and dynamically registers database services with listener. We have a listener called another concept. Okay, let's see. First one is it performs process recovery when user process fails. So PMON functionality is when user process is failed abnormally, it will automatically recover the user process and it will start once again, and the connection is stable for the user, and it frees up the resources in terms we have the user is we have only single user process and we have multiple server process. So whatever once the session is closed, I mean once the user is logged out from the session, we have resources allocated to the user process. So those are cleaned by the process monitor. Yeah, process monitor background process. So this is the functionality of the PMON, and SMON cleans the memory allocated by the session. PMON cleans the resources allocated to the user, and it will have the idle time session out. If for example, if the user is not active since more than 2 minutes or 3 minutes or 5 minutes, it will go into inactive, means the memories are not used by that session. It will monitor that and it will register the users in the listener file. These are the main components of the PMON. And when come to recovery process, it is used with a distributed database configuration, and it automatically connects to other database involved in doubt distributed transactions. It automatically resolves all in-doubt transactions and removes any rows that correspond to it in in-doubt transactions. Okay, let's see what is in-doubt transaction. For example, recovery process is located in database A and we have in-doubt transactions in database B. Let's say database A is a primary database and database B is a standby database. Whatever the transactions are completed and whatever the data is stored in Oracle log files, so it is transferred to standby database automatically. So if the in the time of transferring, if anything occurs wrongly, I mean if because of network issue and whatever it may be, if the file is copied correctly, then only it will look for another file. If the file is not copied correctly, then it will check it, and it will once again have the recovery process checks it, and it will once again have the copy of the same file. That is called recovery process. It will automatically connects to other database involved in in-doubt distributed transactions. It is mainly used in the distributed database recovery process. If we have that configuration, the recovery process will be existed. Yeah, archive process. Archiver process will be exist when the database is in archive log mode. Okay, see, it copies redo log files to a designated storage device after a log switch has occurred. So whatever the data is stored in redo log files, we have it, and when the new data is filling up in the redo log files, the old data will get out from the redo log files. We will not have the old data in redo log files. So if we have the database in Oracle log file, so the redo log files data is stored in the archive destination. So it copies the data in redo log files to the archive log files. These are the physical files. Okay, when it copies, when the log switch had occurred, even we can log switch will occur for every 1/3 of redo log file got filled. Automatically it will log switch will occur. Once the log switch had occurred, the data is copied into the Oracle log file and it is stored permanently. and it also collect transactions, redo data, and transmit that data to standby destinations. Yeah, if the database is configured in standby, so the same RQ log files or redo log files are transmitted to our standby database based on its configuration, whether standby database is configured in physical standby mode or logical standby mode. This is the main functionality of the RQR process. And we have other processes like MON, MMNL, MN, CJQ, and QMNX. These processes will start based on the requirement and parameters which we have declared and based on the performance of the database. Let's see. MON process. MON process performs manageability related background tasks. It performs like managing MON. MON means memory monitoring. So it has the memory management of the background processes. And MMNL process, it performs frequent and lightweight manageability related tasks. MMAN, it performs automatic memory management tasks. See, in 11G we have a new feature called automatic memory management. In 10G we don't have automatic memory management. So automatic memory management means if we declare the memory parameter, for example 2 GB, internally that memory is shared by the SGA components. So if we enable the automatic memory management parameter, this process will be started in the database end. And CJQ process, it runs user jobs used in batch processing. So yeah, when batch processes are scheduled in the database, for example application users needs their jobs to run every day, like for example whatever the data is updated, so they need to update those data into another tables in daily processing. So they will schedule the job in the database level. So in that time this CJQ process will be useful. And QMN, QMN process monitors the streams advanced queuing message queues. So like I said, streams. So when the data is used for replication, means we are copying data from one database to another database using streams. So in that time QMNX process is utilized. So these are the not mandatory process. It depends on the functionality and parameters which we have enabled in the database. So these are all other processes. So till now we have done with our logical structure and background which contains of SGA and memory processes like background process like database background process, server process. We have done with our physical structure entirely. Now when it comes with server process, database and buffer cache. See, this is the main part. Just I have explained, like server process will check in the database. I mean, if the data is not existent in database buffer cache, it directly goes into database files and it gets the data. Before getting the data, it's stored in database buffer cache. That is the thing. It is showing the, I mean, this picture is showing you clearly, like we have different types of buffers like pinned buffer, clean buffer, free or unused buffer, and dirty buffer. See, dirty buffer is having modified data and which is yet to write in the database files. And when it's free or unused buffer is like no data in the buffer and it is ready to occupy. And clean buffer is once the data is returned to database buffer, it is going to clean the buffer. And pin buffer is which is presently utilizing, presently utilized by the database, that is called pinned buffer. These are the 4 types of buffers in database buffer cache. See, this is the physical structure and storage of the database. As I said earlier, physical structure contains control files, database files, online redo log files, archived redo log files, backup files if we have backup, and parameter files, password file, alert log and trace file. These are the main files of the database physically which will be existed in the server or in our storage level. See, control file. Control file contains a list of all other files that make up the database such as database files and redo log files. Also contains important information about the contents and operating state of the database. This is the main purpose. Control file, what the control file includes. See, by default in Oracle 10G or 11G, database creates 3 control files. Even though we have multiple number of control file have the same information in all the files. Why? Because we have a mirror copy to in worst case scenarios. If one of the control file we have used, we will have the another control file with the same data. So for this thing, we will the database will maintain 3 control files. If we create the database, it will create defaultly 3 control files. They are mirror images of each other, and the control file contains the name of the database and the database at what time it was created and what is the current state of database. Either is it open mode or read-only mode, and we need any recovery is needed. This type of information is stored in control files, and at what time the database had closed, and what is the interval covered by each archive redo log. And since this is a critical file, you should have more than one control file and they should be on a separate disk drive. We should not keep the control files on the same drive. Each control file should be located in different drives. But if the drive is totally lost, we lose the control file. So if the control file is located in different drives and different location, if one drive is lost, we can have the different drives and control files will be existed. And control file is saved with the extension of .ctl format, and this is a major file. If we lose it, we need to we can only recover if we have the updated control file. If the updated control file is not there, then the no use of having the database. And if we recover also, we cannot able to restore the database up to time. It is a major part. And logical and physical database structures. See, let's have how the logical and physical database structure is involved internally. See, physically data file and OS block is existed, and logical, we are saying database. In database, schemas are logical. We can say table space name. Table space name is logical, but table space is contained of physical data files. Number of one table space can have maximum of 135 to 200 data files, and these data files is again divided into segments. Segment, which is a logical structure, we cannot see it, and again segments are divided into extents, which is also a logical structure. And this totally is stored in Oracle data block, which is in the OS level, which is again comes to physical. So in this total structure, data files and OS block is a physical structure, remaining are logical structures. Tables and table spaces and data files. The table space consists of one or more data files, and data files belong to only one table space. For example, we have 4 to 5 table spaces, and each table space is having couple of data files. So one table space is having A and B data file, and 2 table spaces having C and D data file. So whatever the table space are having data files, those are belongs to those table space only. We cannot share the data files in different table space like that. So users table space is having data file 1 and data file 2 data files like that. So data files, this purpose is to contain the actual data stored in database. It contains users data stored in tables, includes indexes, data dictionary, and rollback segments. So data files have the physical copy of the data. So it will store the data whatever we are doing on the database level. It contains the tables, indexes, data dictionary, rollback segments, and schemas, and data dictionary views, everything. It will store everything data in the data files. Its characteristics is data files are composed of Oracle blocks, which are in turn composed of operating system blocks. Oracle block size ranges from 2 KB to 32 KB. So whenever the data is created, the data block is having minimum size from 2 KB to 32 KB, the block size. So average size is 8 KB. Okay, And data files belongs to only one database and to only one table space within the database. So data files are the lowest level of granularity between an Oracle database and the operating system. When you map out a database into the OS IO subsystems, the smallest unit you can put in any location is a data file. Okay. If you want to copy the database data file from one place to another place, so we need to have certain queries from database level and from OS level, and it is the easy way to copy the data files. If you are doing a physical level backup or logical level backup, the data files is easy to copy, and it is having a suffix called .dbf format, database file, and control file will have .ctl file, .ctl like control file, and .dbf like the DBA database file, and redo log files. Redo log files purpose is to store changes made to database as a result of transaction and internal Oracle activities. So it stores the whatever the changes made in the database. Like for example, we have something data in the database, and user is started modifying the data. So before modifying it, it stores the data in the redo log files. Once the commit is done, the data is flushed from the redo log file, and it is before flushing it's stored in the database. So this is the main function of the redo log files. Redo log files. Characteristics is by default in Oracle 10G or 11G, it contains 3 redo log files. It will create the 3 redo log files. Every Oracle 10G or 11G database must have at least 2 redo log groups. Okay? Just 3 redo log groups. The database will write log entries to a subsequent redo log group when the previous redo log group fills up. See, we have a 3 redo log group, and each group will have 2 redo log files. So when the data is returning into one redo log group, and the remaining 2 will be in, we have 3 states of the redo log files. One is active, and one is inactive, and one is current stage. Active means which is ready to occupy, and inactive which is writing the data into Oracle log files, and current is which is filled up. These three types of states of the Oracle log files. So the database will write log entries to subsequent redo log group when the previous redo log group fills up. So it will write subsequently. As a general rule, there should be one redo log group for approximately every 4 database users that create action queries. So the rule is approximately we need to have one redo log group for 4 database users. That is a rule. And the Oracle keeps track of redo log file by using a redo log sequence number. This number is recorded inside the file as they are used. Yeah, it creates the Oracle internally has its own mechanism by creating a redo log sequence. For every redo log file, it will create a new sequence, and it will store the information inside by providing the naming convention to the file. And the redo log sequence number is different than the operating system file name that is used to identify the physical file. But because it is having its own mechanism to write the data into the Oracle log files or whatever, write the data into data files, right? So it has its own mechanism, and we cannot see in the operating system level. And if the database is in Oracle log mode, full redo log files are copied to Oracle log files before they are reused. Otherwise, they are written over. Yes, exactly. As I said earlier, if the database is in Oracle log mode, before reusing the redo log file, that data is written into the Oracle log files. If the database is not Oracle log mode, it will be reused, and whatever the data is there, it gets flushed out. So we will be more benefit if we have the database in Oracle log mode. And the suffix used for this is .log. This is about the redo log files. And see, as I said, the segments, logical structure of the database like segments, extents, and blocks. Segments exist in a data table space, and extents exist in the segments. Segments are collection of extents, and data blocks is a part of each segment. Extents are collections of the data blocks, and data blocks are mapped to disk blocks. See how the segment is divided internally. Segment is divided into extents. Extents are divided into data blocks, and data blocks are divided into disk blocks. This is a logical structure which is internally divided itself by the Oracle database. Yeah, this is totally summary which we have discussed till now. So memory structures, process structures, and storage structures. Memory structure is SGA and PGA. Shared global area or system global area and program global area. Shared global area is divided into database buffer cache, relog buffer, and various pools like large pool, Java pool, and stream pool. And process structures like user process and server process and background processes, and storage structure, logical structure, and physical structure. So these are the components of the architecture which we have discussed till now. And I guess you people have got an brief idea how the architecture internally, how the database architecture is internally divided, and how memory structures are shared itself, and what are the mechanism and what is the functionality of the background processes, and how the logical and physical structures are internally correlated based on the requirement and based on the functions of the end user. So I guess you have understood very well about this session. If you have any queries, you can ask me so that I can clarify. Do you people have any queries?
John, Pradeep, Suchitra, do you have any queries? Please proceed.
As of now, I don't have any questions. I understood.
Okay, and remaining people? I guess everyone had understood clearly. Okay, fine. So Jilani?
Hello, Naresh, Jilani here.
Yeah, Jilani.
Yeah, thanks for the demo session. Okay, let me talk to students and we'll update you the status by end of the day. Okay.
Sure.
Okay, guys,
So
please
thanks
email
everyone.
me your feedback. Thanks for joining the demo. Thank you, Naresh.
Thank you. Thanks a lot. Bye.
Yeah, bye, guys.
Bye.